Solar panels have been celebrated as the ultimate solution for clean, renewable energy. From rooftops in California to deserts in the Middle East, billions of dollars have been invested to harness the power of the sun. But what if I told you solar panels, the very symbol of the green revolution, might soon become outdated? Today we'll explore why traditional solar panels have serious limitations and how three breakthrough technologies, perovskites, space-based solar power, and nuclear fusion, could reshape the entire energy landscape. Stay until the end, because the last technology we'll discuss has been called the holy grail of energy by scientists worldwide. At first glance, solar power feels perfect. The sun beams more energy onto Earth in a single hour than humanity uses in an entire year. So why haven't solar panels already solved the world's energy problems? Here's the truth. Traditional silicon solar panels are far from perfect. Their efficiency is usually between 15 and 22%. That means nearly 80% of the sunlight that hits them is wasted. Then there's the issue of intermittency. The sun doesn't shine at night. On cloudy days, efficiency drops dramatically. This forces countries to rely on expensive batteries or backup power from fossil fuels. And let's not forget the lifespan problem. Panels typically last 20 to 25 years, after which they degrade and need replacement. Millions of tons of solar waste are expected by 2050. A problem very few people are talking about. Even cost, which has dropped significantly, isn't the full story. Yes, panels are cheaper, but installation, land usage, and energy storage make the entire system expensive for large-scale adoption. In short, solar panels are good, but maybe not good enough for the future. Enter perovskite solar cells, one of the most exciting materials in energy research today. Perovskites are a class of crystals that can absorb sunlight incredibly efficiently. Unlike bulky silicon panels, perovskites can be printed onto flexible sheets, sprayed like paint, or even layered onto windows. Imagine every skyscraper in New York or Dubai generating electricity from its own glass. The numbers are even more impressive. In just a decade, perovskite efficiency has skyrocketed from under 4% to over 25% in lab tests, nearly matching silicon, but with the potential to go even higher. And here's the kicker. They're much cheaper to manufacture. A world where solar panels are as cheap and thin as wallpaper could change how we think about power forever. The challenge? Durability. Perovskites degrade quickly when exposed to moisture and oxygen, but researchers are racing to solve this, and some early commercial products are already on the horizon. Now let's go beyond Earth. What if solar panels could work 24/7, unaffected by clouds, night, or weather? This is the idea behind space-based solar power. Massive solar arrays would orbit Earth, capturing sunlight all the time and beaming the energy back down using microwaves or lasers. Science fiction? Not quite. NASA and the European Space Agency have already tested prototypes, and in 2023, researchers at Caltech successfully transmitted solar energy from space to Earth for the first time. The potential is staggering. A single square kilometer of solar panels in orbit could generate as much power as an entire nuclear plant on the ground. Of course, challenges remain: launch costs, safety of microwave beams, and maintenance in space. But with reusable rockets from companies like SpaceX dramatically reducing costs, space-based solar might move from theory to reality sooner than we think. Often called the holy grail of energy, fusion is the same process that powers the sun itself. Unlike today's nuclear plants, which rely on fission, splitting atoms, fusion combines lightweight atoms like hydrogen into helium, releasing massive amounts of energy in the process. Fusion fuel is almost limitless. The best part? Just a few liters of seawater contain enough hydrogen to power an entire household for centuries. And unlike fossil fuels, fusion produces no greenhouse gases, and unlike nuclear fission, it leaves behind virtually no dangerous, long-lived waste. In 2022, U.S. scientists at the Lawrence Livermore National Laboratory made history by achieving net energy gain from a fusion reaction, a milestone many thought was decades away. Since then, private startups and governments alike have poured billions into making fusion a commercial reality. If successful, fusion could provide clean, safe, and practically unlimited energy, making traditional solar panels seem like stepping stones from a primitive past. So, does this mean solar panels are doomed? Not exactly. In fact, solar will likely remain a critical part of our energy mix for decades, but it may not be the ultimate solution people once believed. Think of it this way. Horses weren't useless after the invention of cars. They just stopped being the main mode of transportation. Similarly, solar panels may continue to play a supporting role, while breakthroughs like perovskites, space-based solar, and nuclear fusion redefine the future. The question isn't whether solar panels will vanish. It's whether we're ready for a world where they're no longer the star of the show. So what do you think? Will solar panels be replaced, upgraded, or integrated into these futuristic systems? Drop your thoughts in the comments below. And if you enjoyed this deep dive into the future of energy, make sure to hit like, subscribe, and stay tuned for our next episode, where we'll explore the strangest energy sources you've probably never heard of. Because the future of energy is only just beginning.